Lowest structure for oxygen difluoride. Let's start by counting the total number of valence electrons available. Oxygen contributes 6 valence electrons. We know that it's in group 16. So just check out the last digit of the group number to get the number of valence electrons. Fluorine is right next to it in group 17. So it contributes 7 valence electrons each. There are 2 of them. 14 plus the 6 gives us 20 valence electrons to work with in this lowest structure. The less electronegative atom in this case is oxygen, so we're going to put that in the center, and we'll surround it with the 2 fluorines. We're going to need a bonding pair, in other words connect these atoms, and that's going to use up 4 of our valence electrons. Each bonding pair is a pair of electrons that are being shared. So we're down to 16 valence electrons. The next step is to give the terminal atoms the octet. So fluorine already has 2, so we'll give 6 more to achieve the octet. On both sides, that uses up 12 more. So we are down to 4 valence electrons. We'll put the remaining 4 around the central atom, and there's your lowest structure, 4 oxygen difluoride. Now this is not a linear molecule as the lowest structure, this lowest structure might predict. So we'll have to turn to VSEPR. In that theory, we take a look at the central atom here is oxygen, and we count the number of regions of electron density around that central atom. So there are 4 regions of electron density. When you have 4 regions of electron density, where the steric number is 4, that means the parent geometry is tetrahedral. That means the bond angles are roughly 109 degrees. Now, 2 of the 4 are lone pairs. In other words, they're not bonded to other atoms. So the actual geometry of that molecule is going to be bent. And because lone pairs have more repulsion than bonding pairs, they're going to squeeze this angle between the fluoride, oxygen, and fluorine. That angle is going to be much less, or let's just say less than 109. Probably close to 104. Alright, so let's draw that 3-dimensionally, or try to. So got oxygen, and let's draw one of the fluorines right on the plane of the screen here. And then the other one about 104 degrees, right on the plane of the screen. And we got 1 pair of electrons. This one's coming right at you, out of the screen towards you. And then we have another pair kind of going behind the screen. Right, so this is less than 109. And we would say this is a bent shape molecule because you don't see this part, you only see the part that's connected to atoms. So there's your bent shape.